Greetings, everyone. Today we're going to explore solving two-step equations. For taking notes, you'll want to make sure that you have your notes book that was provided to you in class. If you don't, you'll just have to pause once in a while to write down the equations. Keep in mind, this is one of the first times you're taking notes this year, and I always try to put a little pencil on the slides where we have required information to write down. All right, let's start off by talking about a few quick vocabulary terms. In this example, I have an equation, 5x plus 4 equals 24, and each part has a special name. The number in front of the letter is called a coefficient. Coefficient is always any number in front of a variable. The letter is more properly called a variable. Now, what if a number doesn't have a letter? Then we call it a constant. A constant remains constant. It's just the number that it is. All right, a quick review of last year. When solving one-step equations, or as we're going to get into multi-step equations, you want to make sure to understand the inverse operations. A generic way to think of inverse is the opposite. So what's the opposite of addition? Subtraction. What's the opposite of subtraction then? Addition. What's the opposite of multiplication? Division. And the opposite of division? Multiplication. Make sure you understand those. Remember, that's part of PEMDAS. And you just want to know what is always the opposite. All right, so let's quickly review one-step equations. On this first example, I typically recommend drawing a line down the equal sign. It helps you remember that you're balancing an equation. So if I want to isolate the a, it says subtract 10. So what's the opposite? Adding 10. Now these are work steps that I want to see. The opposites cancel out because negative 10 and 10 is 0, right? So I have a variable of a remaining, and then I have just a regular calculation to take care of. Again, I encourage you to draw a line down the equal sign. I know it seems silly when these equations, but when we end up with 5 or 6 steps, it'll be very helpful. So currently I see that I'm taking the letter and dividing by 3. So the opposite would be timesing by 3. The b is remaining, and I have my solution. So let's add on the second step, because that was a review. This is likely also a review. But the order in which you perform those inverse operations matters. You want to add or subtract first, and then undo any multiplication or division. So if we think back to PEMDAS for a moment while you write that down, PEMDAS was simplifying expressions. When you solve equations, you go the opposite way. So you're starting with adding or subtracting, and then taking care of multiplying or dividing. So let's practice these steps. Again, I encourage you to draw a line down the equal sign. We want to undo any addition or subtraction. So instead of subtract 8, let's add 8. Now, how do I know which number to add or subtract? Well, look at the side that has the letter, right? Our end goal is to isolate a variable. Next step, undo any multiplication or division. This says x is being multiplied by 3, so I want to undo it and divide by 3. There's our solution. All right, this next example in your foldable, if yours looks like mine, it hasn't been fixed. We have a little typo. So can you please do me a favor and just cross off this last x? If yours already looks like this, perfect. All right, let's solve without that. We haven't learned that yet. So we're going to draw a line down the equal sign. We want to undo some addition or subtraction. So I see that I'm adding 2, so I want to subtract 2. Now you might be thinking, but there's decimals. That's fine. You can use a calculator if needed, but if I subtract 2, I'm at 7.4. Next step, undo any multiplication or division when two things are next to each other. That implies multiplication. So we're going to divide by 6.4. Now, do I expect you to know what that is off the top of your head? Nope. You're going to use a calculator, so type it in. 6.4 divided by, 7.4 divided by 6.4. And you'll notice we get this kind of crazy decimal. It is terminating though, and that's okay. Write down that decimal. Make sure to follow directions. Occasionally you might be told to leave things as a fraction or a decimal. Since this started with decimals, we'll end with decimals. Now these last two examples are unique. We're going to begin by drawing a line down the equal sign. The first goal is to undo addition or subtraction, and I can see that I have a clear -2, so I'm going to add 2. Now here's where it gets a little tricky. I have a fraction. Now some of you remember these rules perfectly, and I will show you that sort of one-step way to solve this. But those of you that are confused by this fraction, let's break it up. This is the longer way, but let's see if it makes sense. I see that there's a divide by 4. Let's take care of that first, right? Then we don't have a fraction. Instead of divide 4, let's times 4. What does that look like then? The 4's go away. I have a 3 and an x that fall down next to each other, and I have a 12. See how much easier? Even though it was a fraction, it didn't matter. We took care of the division first. Now it says undo multiplication. So we're going to divide by 3. You see how that worked out? Now, those of you that are like, that's not how I learned it, let me show you maybe the way that you learned it. We see multiplying by a fraction, and we don't divide by fractions. What we can do, and what you might have learned in the past, is to multiply by the reciprocal. Multiply by the reciprocal. So if you multiply by the reciprocal, that cancels the entire fraction at once. When you multiply fractions, you'd have 12 over 3, which is just 4. So I want you to take a look. You decide, does the red side make more sense or the green side? Doesn't matter to me what you do. And if you're really confident with your calculator, go ahead and utilize that fraction key. Now, please put a star by this one in your notes, okay? This one is unique, and it's an exception to the rule. I typically say undo any addition or subtraction, so my eyes are drawn to this -4. But the 3 is in the way. Do you see how it's literally a wall blocking me moving that -4? I can't. If there is a division that's taking over the entire problem, right? It's like that person that just takes ownership of the whole room and you're like, no, we need to move on with what we're doing. To get rid of that, you need to take care of that first. Instead of a huge divide by 3, let's get that 3 out of the room so we can move on. If it's taking over the whole problem, you don't want it. Okay? So there's a difference. Look back at example 5. See how it was a tiny fraction, or example 2 was a tiny fraction? This one's a huge fraction. If it's overpowering the entire problem, get rid of it. Okay, so that's why there's a star there. This is special. You can use your notes on your homework and reference this. Now if I look at that z, that z says it's adding a -4. So instead of -4, we're going to add 4 because that's the opposite of negative. That leaves me with a positive z and a 34. Okay, so watch out for those special huge fractions. Alrighty, those are our notes for today. Make sure if you have any questions to ask, as always, check out Google Classroom. Everything is posted there. What do you need? And don't forget about the Saber Center, right? You can walk in and ask for help on your homework if you need at any time. So make sure to check that out. And until next time, have a good one.